Good Friday morning, everybody, and welcome to our Friday morning virtual learning class. Not too many left of these online academy Friday morning virtual videos. We're coming to the final few weeks of school. Matter of fact, while I do a quick count here, we have, not including this Friday here, we have one, two, let's see here, three, four, five. Only 5 more Fridays left. We're really getting down to the nitty gritty here. We're getting down to the end of the fourth quarter, the end of your term and your time in the elementary building, and you guys are more than ready to go on up to Dempsey Middle School. It will be a wonderful experience for each and every one of you. I know some of you guys are maybe even going to different schools. I know Alexis is thinking about maybe going to a school in Springfield. But wherever you go, I want to say good luck, and you guys are going to do really, really great there. There is some kind of sad news to share. Online Academy, that was something that we've done this year. We piloted this year with with everyone here. It will no longer be. Next year, there will no longer be an online academy. There was a time they thought that there would be an online academy, but due to staffing shortages and student interest, it didn't seem like it was something the district wanted to go with, as it was voted down at the board meeting earlier this week. So I do want to say it's been great working with you here, and it's been a lot of fun, and it's been a great learning experience for me too, having to really challenge myself to learn all of these online cool things. So I'll get to use this stuff next year. Maybe it's at least a version of it within the 5-day in-person classroom. So thank you for giving such a wonderful year. And I know I'm going to keep saying that as the year goes on, and we're ended another 5 to 6 weeks. But it's been an exciting time for everyone, including myself. So just to kind of start off with what we got going on this week. Obviously, this Monday, you guys took your math State of Ohio test, and we finally have our last State of Ohio test coming up this Monday, which is everybody's most favorite, which is science. And that one, again, will be at Willis. No, we'll do both part 1 and part 2 in the morning. I know we've been really pushing science this past week and a half to get us prepared for that test. So, an interest of kind of doing fun. I usually kind of look at some of the readings we're going to do and try to find some things that, tie in with our lessons. But today, I just found a funny, kind of a funny, interesting reading for this morning. And it's called Slim Jim. Slim Jim Rides the Range. So you can see here, you got a cowboy here. You got a horse with eyes looking at this cowboy. He's like, what is this guy doing? He's got some interesting pants. He's got a cool shirt. It looks like a bolo tie and a big 10-gallon bucket hat. So let's see where this story is going to take us. So, Slim Jim. When Slim Jim got a new job at the Baggy Pants Ranch, she was pretty excited. Hoo-wee, he said. I've always wanted to be a cowboy. Slim Jim pictured himself sitting tall in the saddle. In no time at all, he will be riding and roping. He'd be at home on the range. He couldn't wait. You can see this guy. His dad looks like he's overwhelmed. Or maybe he's a single dad, just, he really loves cats, and that's who he's cooking for. He's got some beans going on here. I don't know what he's got going on here. But anyway, he's got a lot of dreams going on in his head. At sunup on the first morning, Slim Jim was sprinkling a pinch of cinnamon on his mush when Zach Dazzle rode up to the bunkhouse. Zach owned the ranch. This is it, boys, he cried. It's time to saddle up. And this is cattle ranching time. We're going on a cattle drive. Slim Jim ate breakfast faster than a wildfire burns through dry grass. And we saw a video of that earlier this week. Remember the gazelles were running away from that wildfire? Then he grabbed his hat. He hopped into his boots. He strapped on his chaps and slapped on his spurs. He was ready to go. You ride, Charlie, said Zach. He pointed to a bony brown horse. Yeehaw! And yes, sir, said Slim Jim. So these things are called chaps right here. They kind of go over the legs. I don't know, maybe I'm not too familiar with horse riding, but I think maybe they protect the legs a little bit from the dirt and the pants and all the rubbing and things that could go on there. That's what I'm assuming anyway. Slim Jim tried to swing up in his saddle. He jumped and he slumped. He slipped into it and he flipped. He tangled and tumbled. Riding was a lot harder than it looked. At last, Slim Jim was sitting in the saddle, but staying on was the tricky part. He fell off Charlie when they got to the fence post. He fell off Charlie when they got to the trail. He fell off again when they got to the creek. Zach Dazzle rode up alongside him. "What in the world is the matter with you?" said Zach. Have any of you guys ever ridden a horse? Have you ever, seen any horses close up? What kind of experience level do you have with the horse? The only experience that I have with a horse, let me see. I don't think I've ever actually touched a horse. I've seen them, right? I know a lot of in my high school where I grew up, they did a lot of like horse jumping. I think it was like equestrian. I know they had polo. They would play that. I kind of went and watched a little bit. It really wasn't my thing, but it was really cool. It was really, I know a lot of really talented people there, and obviously talented horses, I would imagine. But it was really cool. I know it's definitely something that takes a lot of skill to do, and just simply something I just didn't have the skill to do. So maybe some of you guys, or maybe some of your parents or aunts or uncles or brothers or sisters, maybe they are good horse riders, because we are the Delaware Pacers. "I can't remember the last time I was on a horse," said Slim Jim. "I must be rusty. I'll be fine with a little more practice." "I hope so," said Zach. The next morning, Slim Jim woke up. He was stiff as a board, and he was black and blue from his chin to his shins. He did not want to spend one more minute on Charlie's back. "Hurry up with those ropes, boys," Zach Dazzle yelled. "We got strays wandering all over the place. Round 'em up." Roundup time. Slim Jim grabbed his rope, he flicked it and flipped it, and the rope drooped like a wet noodle. Slim Jim twitched and twanged, but the rope dangled and tangled. He twirled and swirled it. The rope curled around his knees and knocked him flat. "Now what?" said Zach. "I can't remember the last time I handled a rope," said Slim Jim. "I'll get the hang of it." "See that you do," said Zach. The next day, the Cowboys moved the herd on out to the range. I know there's one place where I ride my bike here. It's kind of in New Albany. And there's these group of horses, and these horses all have these long horns on them. I always think it's kind of cool to see those, because they're big, like they're long. I mean, the name Longhorn is no joke. Like, they're huge and long. And it's right here in just New Albany, Ohio. Just outside of Gahanna, just outside of Columbus. It's not that too far away to see that these horses with these big old horns on them. "Kerchoo!" Slim Jim pulled his red banana. "Kerchoo!" Charlie bucked and whined. "Kerchoo!" Slim held onto the saddle on the horse with one hand and blew his nose with the other. Yeah, I know what that's like. It's allergy season right now. Zach Dazzle rode up alongside him. "What's all the racket?" said Zach. "You're as noisy as a runaway train." "Kerchoo!" said Slim Jim. "It must be the dust. It must be the tumbleweeds. It must be the itty-bitty seeds. They prickle and tickle. They make my nose run. They make me wheeze and sneeze." "Well, you're going to cause a stampede," he said. "The cattle don't like that ruckus. Go back to camp and work on your skills. You need to practice." "Yes, sir," said Slim Jim. Slim Jim led Charlie back to camp. He felt as miserable as a blister at a barn dance. "I can't ride, I can't rope, I'm hopeless making myself home on the range. When it comes to being a cowboy, I don't know beans." Jim sniffled, then he thought for a minute and smiled. He headed to the chuck wagon. Slim Jim took off his chaps and put on his apron. He started a fire and he set a kettle out. He sliced and chopped and stirred and simmered. He tasted and tested. I don't know beans about being a cowboy," Slim Jim said, "but I do know beans about beans." And that evening, Zach Dazzle and the Baggy Pants Ranch hands got back to the camp. Slim Jim was waiting. "What have you been up to all day?" asked Zach. "I hope you have been getting lots of practice." "I've been very busy," said Slim Jim. "Wash up and chow down." Zach Dazzle ate 3 helpings of chili and 2 fat slices of pie. "Listen here, Slim Jim," said Zach. "I want you to stay away from the cattle on the range. From now on, you're in charge of the chuck wagon. No riding or roping required. Do we have a deal?" Slim Jim grinned and shook his hand. "Yeehaw, and yes, sir," he said. And he's been Baggy Pants Ranch cook ever since. A note from the author. That's a pretty good story. During the summer, when I was a kid, I often visited my grandparents in eastern Washington, and I never got tired of hearing stories about growing up on the ranch. My grandmother was an amazing cook, and it was easy to imagine her taking charge of feeding everyone during the roundup or harvest. I did not inherit her knack for biscuits lighter than air, smooth gravy, or mile-high cakes, but I did inherit her love of gathering family around the table at the end of a long, hard day work. Huh, I like that, because it kind of starts off like, hey, this guy really wants to be a cowboy, but he can't, he can't rope, he can't ride, he can't, he can't keep the cows all together. But he did find something to help out, and that was, being a cook. And I think it's important to apply to our lives, is that sometimes we maybe want to be a part of the group. We may want to be this part of the group. We want to be that part of the group. But sometimes we have to find our own way into that group and things that we're good at. And this guy here is a good cook. Maybe he wasn't the best roper, maybe he wasn't the best rider, but man, he's a good cook, and he was accepted into the group that he wanted to be a part of because he was himself at the end of the day. And, it gets kind of ooey gooey and mushy and gushy, but it's true. Do the things you love, and people will, accept you for who you are, and he fit right into that group right there. And it's really kind of cool that this story, kind of reached further beyond than just these pages here. Alrighty, so fix my glasses there. I'll tell you what, my picture of myself does look a little bit grainier, a little bit darker, but hey, new computer problems, huh? All right, so this week we did talk about doing some Lexia. Only asked you guys to do 20 minutes of Lexia, 20 minutes of Lexia. Scoop pad, I will need to adjust that. We did 10 minutes of scoop pad on Wednesday, 10 minutes of scoop pad on Thursday. And so that leaves 10 minutes today. So really, instead of doing 40, remember I took off Tuesday. Let's just make it 30 minutes today. 30 minutes of scoop pad ELA today, 3-0. 30 minutes, is that 30? Or is this looks like 30 to you? Maybe that looks like 30. Or does this look like 30 to you? I can't tell. But anyway, just 30 points of scoop pad this week. Don't worry about getting the full 40. Again, we're kind of shortening things down now that the school year is winding down. Testing season is winding down. Our last test is Monday, so I want to kind of bring that all in line. I'm actually going to skip this and skip that. I'm going to go straight to the mini mystery. Actually, no, I'm not. Sorry, check that. I am going to do the scientific process, then mini mystery science. It'll make sense why, because I want to do this first to do that. So this is called the scientific processing quiz. So what you need to do is go into Canvas. Hi, Canvas. Open up Canvas. Hey, Canvas. And then we go to Science Canvas, the one with Bill Nye, the Science Guy. Bill Nye, the Science Guy. Bill. Okay, open up. Come on, Bill. Bill's taking a while to open up. And then we're going to go to the 16th. Go to the 16th. Where are you at? The 16th of April. Whoop, too far. 15. Uh-oh, where did 16 go? Did I mess something up? What did I mess up here, guys? Sorry, the scientific processing quiz dissection. Whoa. What did I do? What did I do wrong? Oh, there it is. 19. There it is. I was going to say. Whew. I was like, did I lose it already? Couldn't have lost it. Ow! Man, didn't I click the wrong darn thing? Gotta go all the way back. Sorry to make you wait. I just gotta scroll down. Scroll on down. You guys see this cell division and all that. Cell division, you guys do that in 6th grade, so I didn't want to teach you guys that. So, however, we do need to learn about the scientific process. And here it is, scientific process. Sometimes it's called a scientific method, sometimes scientific process. It's all the same thing. Scientific method. We're all scientists. Science has been with us ever since the first child saw a pebble and popped it into their mouth to find out what it was like. It's true. It's science. Young children are natural scientists. They look at the world all around them and try to make sense of it. In fact, we're all scientists. We all want to know how stuff works. Science is all about answering those questions. The scientific method is a way to do it. Children experiment all the time. What happens when I hit a pile of blocks? If I keep filling the cup up with water, will the water stick to itself, or will it run over? What happens when I pull the cat's tail? All that reminds me of Eleanor. As we grow, we move on to the sophisticated questions. Why is the sky blue? What is inside your eyeball? What is the beginning of the scientific process? The process starts with an observation, then a question about that observation. The rest of the process is called the scientific method, is a way to find an answer, or answers to a question. Man, is my computer making all that noise? So we're going to follow our curiosity here with an everyday phenomenon, or explained scientifically. We're going to watch this video about Tom and Rosa, two young visitors to the house of the wise Mrs. Williamson, as they reveal the mysteries behind everyday science. We're not going to be able to watch this entire video. We'll watch most of it, but I do encourage you guys to continue to watch it on your own. It is pretty neat.
I agree. Let's try it.
Take the prism away. We're back to plain white light again.
Sorry.
There, do you see it?
There we go.
I never saw a rainbow before. Today and now I see too. How did you do that?
Let me hold those.
So, how did you make the rainbow happen?
That's the first thing we'll talk about when we get inside. I'll turn the water off and meet you there. You'll find some juice on the dining room table. We can all make a kind of rainbow inside too, using a prism. A prism has flat, angled sides. It's solid and transparent, which means you can see through it.
Guys, have any prisms at your house?
A prism can separate the white light into the colors of the spectrum. The prism separates the light and forms a flat sheet of colors instead of a rainbow. Let's experiment and put the prism in sunlight and look at the white piece of paper I put on the other side of the room and see the split or separated colors on the paper. What do you think will happen if we take the prism away?
We won't be able to see the colors again.
I agree. Let's try it.
Take the prism away. We're back to plain white light again.
Any conclusions?
That must mean that the rain acts like a prism to bend the sunlight. And without a prism to bend the sunlight, we can't see all the colors.
Good, Tom.
Let's see the colors again.
These are the same colors we saw outside. What do you see?
There's red, orange, yellow, green, blue, purple.
You were observant to hesitate, Rosa, because there's another color in there. In the spectrum of colors a prism makes, we call the second blue indigo, and the purple color is called violet.
It's really beautiful.
A great way to remember the colors of the spectrum is an acronym that spells out the first letter of each color. In this case, a man's name.
Roy, red, orange, yellow.
G is for green, and B-I-V is for blue, indigo, and violet.
Roy, G, Biv. Excellent.
I still don't understand why we don't see a rainbow every time it rains.
Maybe if it's too cloudy, there isn't enough sunlight to make a rainbow, like we just saw.
But the sun is there above the clouds, but we just don't see it.
Well, you're both right. To see a natural rainbow, conditions have to be just right. And there have to be water droplets in the air, too, even if we can't see them. Speaking of water, I'd like a glass. You kids still thirsty?
No, I'm fine.
No thanks.
Let's talk about my glass of water for a minute. If I put an ice cube in my glass of water, where do you think it'll go? Sink to the bottom, settle in the middle, or float to the top?
The top. It's kind of on the water. Is that because ice is lighter than water?
Ice is water, just frozen water. How can water be lighter than water?
Then why does the ice float?
An important question. Let's try something. Since the ice is above the water, you might think that as it melts, the level of the water will rise. Should we worry that as the ice melts, the liquid will overflow? I'll tell you what. I'll add some more ice so the glass is really full. You know the expression, a watched pot never boils? Could it be that watched ice never melts? Why don't you watch it for a while? Observe what happens while you finish your juice.
I think it will overflow.
I think it will too, and it's going to get all over the table. Maybe we should take some ice out so it doesn't overflow.
While we're waiting for the ice to melt, let me show you something. I put a tiny amount of water in this little Pyrex dish that could be frozen safely. And it's just beginning to freeze, kind of like a little pond in winter. The ice is strong enough to hold a little bit of weight. But if we put too much weight on the thin ice, the ice won't be strong enough to hold the penny, and the penny sinks to the bottom like a skater falling through thin ice. The penny goes to the bottom, and pieces of ice float. So remember, when you're told don't walk on the ice, it's too thin, you're the penny.
You're
now,
the penny.
Should we try
Yeah,
this again
so,
with a toothpick?
I think she does a good job explaining some just basic phenomenon. But the point of that is she's using the scientific method there, making observations and then applying them to questions. So, true or false? Hypotheses have not been proved by test. Theories have been proven or confirmed, but not by tests. True. What is the step you take before you make a hypothesis? You ask a question or make an observation, just like they did. They asked a question, I think the ice is going to overflow, or I observed that the ice is melting. One of the strengths of the scientific method is that if your experiment is repeated by anyone, anywhere, the results should be consistent with yours. In this context, what does consistent mean? It means their results should agree or match your results no matter what. And if they don't, then it's not consistent. So, begin the scientific method. What is the first step to finding answers? Whether you start with a problem, why is my plant dying? An observation, those ants are carrying away leaves. Or a question, why are those ants carrying leaves? You are ready to begin. Your next step is to write down what you already know. You may want to do some background research during this step. And that's important. We can't skip over the background research because it helps you understand what's going to happen next or could happen next. In studying the ants, you know that you are in a park, an area that is undisturbed, where there are trees and leaves. You know that these are ants and that they are definitely carrying leaves or parts of leaves from a nearby tree. You might add other observations too. For example, you might follow ants in to see if they prefer one kind of leaf or if they communicate with each other. Now you want to know more. So, how do you get to know more?
Insects are discerning lovers and sometimes good parents. They are unquestionably hard workers. And these traits are probably at the heart of their crowning achievement: large, complex communities.
Isn't that cool? How big that is from an ant?
The insects that built this remarkable structure in Argentina prosper thanks to skills that seem almost more human than insect-like. It's a bustling metropolis home to millions of ants. A colony this large needs a huge supply of food. It's surrounded by grass, but the ants can't digest a blade of it. Nonetheless, with a single-minded determination, they set off to collect it. But why?
Uh-oh.
Insects have evolved some of the most sophisticated societies on Earth. Communities that are the closest things in nature to human cities. These Argentine ants are heading out from their colony to mow the grass.
I need them to come into my house.
The heads of these big-jawed individuals
Whoa, look
are
at them
not
just
full
chewing
of
that
brain,
thing up.
but brawn. They are enormously strong and give the species its name: grass cutters.
Get it, buddy.
They work all day,
Oh
every
my
day.
gosh. You can do it. Almost. Come on. Hey, did he just fall off? He fell off too.
Ants, like beetles and all insects, have hard external shells, so they take their falls in stride.
Yeah.
The key to the grass cutter's success is division of labor. The smaller ants down on the ground are porters. Their job is to carry the grass segments back to the colony.
Dude, they're strong.
The porters, too, are strong for their size. But balance can be an issue.
Yeah. Yeah.
Columns of them carry the grass back to the nest along highways engineered just for this purpose. The various members of the colony function as parts of a well-oiled corporate machine. But as in human societies,
It's pretty
not
cool.
everyone is a team player.
Sorry, guys, so
A
pixelated there.
hitchhiker makes one
Look at that.
ant's job a lot
It's a
harder.
little better.
And this guy's not with the program at all. This isn't even grass.
That's what I'd be doing. Carrying the wrong thing back. That is cool. Wow. Wow. Look at these things. Look at them go. These ants are crazy.
A single colony harvests half a ton of grass a year. But since they can't eat it, why do they go to all this trouble?
Yeah.
The answer lies underground, in the nest. The grass cutter ants have one of the most extraordinary survival strategies in the insect world. They dig a network of tunnels that extends downward for more than 15 feet.
Whoa.
And there, at the heart of the colony, lies the key to their survival. A fungus. A fungus that's found nowhere else on Earth.
Ugh.
The ants cultivate it as if their lives depended on it, which they do. And this is where the inedible grass comes in. The big-jawed ants chop up the grass, covering it with an antibiotic saliva that kills every kind of fungus,
Oh.
except this one. The ants are farmers. This is agriculture. The grass is fertilizer, and the fungus is their food crop.
Oh, I don't know if I can take any more of that. So they take the grass back, let it decompose with the fungus, and then they eat it. Oh, that's nasty. I thought what my wife made for dinner tonight was nasty. Oh, jeez. Woo. Alrighty, so ant colony facts. Here's a cool ant colony fact. This is called Magic School Bus. They were supposed to make a new Netflix series out of it, but I don't think they ever did. But I know your parents definitely know what Magic School Bus is. It was one of like our cool shows as a kid.
Is this the magic school bus? Is this the magic school bus? Is this the magic school bus? 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 I want the magic school bus! I want the magic school bus!
Okay, Liz, I promise I'll let everyone know how much work you did on that movie.
Miss Frizzle.
Just let me take this call, okay? Hello.
Hi, you work on the Magic School Bus show, right?
You bet. I'm the producer. One of them.
I know for a fact there are thousands of ants in an ant colony, but in your show, I only counted 137.
Well, I guess you must be an account ant. Get it?
Oh boy, now
Bad
I know
jokes.
who's responsible for all those terrible puns.
Ooh, ice cold.
Well, actually, you're right. There are thousands of ants in one colony, but we couldn't afford to hire that many extras.
And there are also thousands of different species of ants. You only showed one kind of ant.
Right again. There are about 10,000 different kinds of ants, more than all the other social insects put together.
And you didn't say a thing about the fact that all the ants we saw were female.
Well, yes, we feel quite repentant about that.
Now, almost every ant in the colony is female. The only thing the few males do is mate with the queen. Anything else?
Yes, ants use pheromones for more than telling friend from foe. It's how they communicate where food is. If the nest needs repairing, they smell pheromones like we hear words.
You know, kid, I have to say, you're pretty darn smart.
Actually, I'm brilliant. Gotcha.
One more call and that's it. Promise. Hello, Magic School Bus.
This is the Oscar Awards Committee returning your call.
Yes, I just had a question about the rules. In the category of best camera work, is it possible to nominate a lizard?
So that's like, I don't know. I mean, I'm oversimplifying it, but basically, I guess you could say in a way that Magic School Bus is kind of like Brain Pop, but Magic School Bus goes a lot longer than Brain Pops do. So, but basically the same concept, educational videos that are kind of funny, especially at the end of it. But the difference is one has Miss Frizzle and the other one doesn't. How can you be sure that your experiment will answer your question that you're asking? Anyone can use a scientific method to answer questions and explain observations. This video below shows you how you can create your own experiment using a scientific method. Oh, sorry. I realized I can hear that really well, but my AirPods.
Let's look in more detail at scientific method using another of life's basic questions. How does light affect the growth of plants? The answer may seem obvious, but let's see if that's still the case after we've applied the process of scientific method.
It sounds like cicadas. They'll be coming soon.
First, we make some observations. Most plants seem to grow in areas that receive light.
Okay, so there's plants growing here where the sun's coming through.
Yeah, right.
Some flowers open during the day and close at night.
That's cool.
Not much growing in there.
No.
And we find very few plants in dark places, such as the rainforest floor. Seeds germinate underground, but they are soon exposed to light. These observations lead us to the question, do plants need light to grow? The next step is to formulate a hypothesis or an educated guess that addresses our question. A hypothesis represents a prediction, so it is always a statement rather than a question.
Well, all we need now is a hypothesis. So, do plants need light to grow?
No, the hypothesis should be a statement, so it should be plants need light to grow.
Yeah.
Now we need to test our hypothesis by designing an experiment and making observations. The first step is to identify all the factors that could influence our observations. These factors are known as variables. The growth of plants could be affected by the presence or absence of light, the amount of moisture in the soil, the type of soil, and the temperature of the air. To check for the effect of just one variable, in this case light, we need to change only this variable while keeping all the others the same. To do this, we need to set up an environment where we can control all of the variables. A seed box like this one does the job nicely. First, we make a bed of vermiculite and cotton wool and add a fixed amount of water. Then we distribute alfalfa seeds evenly throughout the tray. We can then cover 1/2 of the box so that it receives no light and set it in a sheltered area near a window. This way, all of the seeds are grown in the same material, with the same amount of water, at the same air temperature. The only difference between the two sides of the box is exposure to light, the variable we are trying to test. Now we're
That's kind of cool. So, little quick check here, self-check here. True, false. The scientific method was developed to help scientists organize the process of problem solving. Yep, true. Sometimes the most challenging part of an investigation is developing a good hypothesis to your investigation. So, what is a hypothesis? A proposed explanation, your best guess for a phenomenon based on your observations made as a starting point for further investigation. When you have observed something interesting or you have encountered a problem that needs to be solved and you have a proposed hypothetical explanation or solution, what's your next step? You got to design an experiment. This is the fun part. You investigate to test your hypotheses. Plan your own investigation. You may have already had a science investigation question in mind, something we've been wondering about. For instance, you may be wondering if milkweed bugs have a preference of color or a place where they lay their eggs. Haven't you ever wondered about that? Of course, you may not be interested in milkweed bugs. Perhaps your family uses multiple different kinds of sweeteners, sugar and honey, and the one in the pink packet and the one in the yellow packet in your drinks. There are even newer sweeteners made up of plant extracts like stevia. Perhaps you have wondered whether sugar substitutes are sweet as real sugar and whether or not they actually taste like real sugar. If you're struggling to come up with an idea for your investigation, many ideas for investigations in the physical science and earth science and life science. If you aren't interested in sweeteners, try searching the internet for a couple ideas. All right, so that takes you guys to your quiz. Oops, I'm like skipping out. There it goes. Take you guys to your quiz. That's not it. Let's see. There it is, a scientific process quiz. My mouse pad's moving, so when I move this, the mouse pad goes with it. The next thing I do want to do is the mini mystery science. So we're going to go into Canvas. We're going to open a new page in Canvas, and then we're going to go into where it says Online Academy Doodly 21, and then we're going to go to discussions. And I enjoy getting these discussions. And this one is the one that's due on April 16th. So it's loading it up, which is number 25. I have 26 there for next week. Here's 25. So before we get started in discussion, what do you think the fastest baseball ever thrown is? How do baseball players throw so fast? And after you watch the video, answer question number 3. What was the most surprising thing about Doug's sports gear? So baseball season has started. Just started maybe a week or two ago. And we have 2 baseball teams here in Ohio. You have the Cleveland baseball team, which is up north in Cleveland. And then you have the great team in Cincinnati, the oldest professional sports team, the Cincinnati Reds, quite possibly the best team ever. Can you tell I'm from Cincinnati? That's my favorite team. Oops, I put the wrong link in there. Oh no! Oh no! Let's see if I can fix that link. This is not the right one. Let's see here. Let's see if I can fix the link. Yeah, glad I should have done this before, but there it is. I need to go into here. You get to see the inner workings of how I do this. So I need to hit share student link, because if I share my link, it's not going to work because this is a paid program by me. So I need to go here, and then I go, whoops. I did it again. Sorry. I go here, and I go, come on. It's not supposed to do that. I swear. Oh, because I need to go to edit mode. I'm not in edit mode. That's why. That's why. I have to edit mode. Then I click this, and then I go link options, and then I replace that link. I hit enter. It's in there. Then I gotta go down and hit save. Move myself out of the way there. Put it back. And now it will work. Alrighty. So what is the fastest baseball ever thrown? Let's listen to that? Make your guess before you watch this. Make your guess in the discussion. Come on, play. Oh, Duggars.
Hi, it's Doug. This is professional baseball player Jim Abbott.
Jim Abbott.
He's considered by many to be one of the best baseball throwers or pitchers that's ever played. What makes him even more incredible is that while the players he played against used two hands, one to catch and one to throw, Jim Abbott had to do it all with one. That's because Jim Abbott was born with only one hand. But that didn't stop him from being an amazing player. You notice how he switches his glove super fast? That's so that he can throw the ball after he catches it. So cool. Someone named Eli has a question about baseball. Let's give Eli a call now.
Hi, Doug.
Hi, Eli.
I have a question for you. What is the fastest baseball ever thrown?
That's a great question. Now, technically, the answer to this question is that the fastest baseball ever thrown is this throw right here.
Oh.
You see that? These are astronauts playing baseball on the International Space Station. And that baseball they threw, it's traveling nearly 17,500 miles an hour. That's more than 150 times faster than any baseball player has ever thrown. Wait, what? It didn't look like it was that fast. Well, that's why I said technically. The space station is high up in space, circling around the Earth at a speed of 17,500 miles an hour. So anything thrown while on the space station is also going 17,500 miles an hour, plus a little bit. Okay, but that's not really what we have in mind when we wonder about the fastest baseball ever thrown. What's the fastest baseball ever thrown down here on planet Earth?
Aroldis Chapman.
Well, first of all, just to give you a sense of a usual speed for a pitch, a typical grown-up can throw a baseball about 40 to 50 miles per hour. That's about twice as fast as the fastest human runners on Earth. But there are some people, like people who throw baseballs for a living, professional baseball pitchers, that can throw a lot faster. And some of them aren't even adults. Like Rain Pagem. Rain can throw a baseball over 80 miles an hour.
Dang.
That's faster than the cars you see speeding by on the freeway. And get this, Rain is only 15 years old. And check out Jordan Hicks. Jordan is one of the fastest pitchers in the world. Jordan's throws go more than 100 miles per hour. Whoa, that's really fast. So how do people like Rain and Jordan throw that fast? I mean, the typical kid can't even throw half that fast. Do these baseball pitchers have some superhuman powers? Before I say anything more, I'm curious. What do you think? How do you think baseball players throw that fast?
Go ahead and put that in the discussion board post, please.
Now, I don't know how you answered, but you may have thought that professional baseball pitchers are a lot stronger than most people. And that makes sense. It seems like you would need to be really strong to throw a baseball that fast. Check out these chimpanzees. Though they look kind of small and cute, chimpanzees are a lot stronger than human beings, and they could easily beat a grown-up in a wrestling match. So if being strong is the most important thing, then chimpanzees should be able to pitch a lot faster than humans, right? But they can't. In fact, a lot of kindergartners can pitch faster than a chimpanzee.
Oh, that guy's awesome. Good for you, buddy.
So if being strong isn't the main thing, what is? Well, when you throw something, it's not just about the muscles in your arms and shoulders. The bones in your arm and shoulder have to move together as well. And our bones are connected to each other by rubber band-like things called ligaments. Watch this. Notice how baseball pitchers twist their bodies around when they pitch? When a pitcher winds up their body and pulls their arm back, the ligaments in their arms stretch out and get ready to make the ball blast off. See how this pitcher pulls his arm way back? He's stretching his ligaments out as far as he can, which builds up energy in his shoulder. It's exactly like when you pull back on a rubber band,
Needs a little work.
like
This
on a
technique
water
there.
balloon launcher. The more you can stretch it back, the faster the water balloon is
Dude,
going
I
to
used
fly.
to do this all the time.
When the
Three-man
pitcher
water balloon
releases the
launchers.
ball, it's just like letting go of that rubber band and launching the water balloon. And all that energy gets released into the ball. Okay, so if what makes a pitch fast is learning how to wind up and stretch your ligaments out as far as you can, does that mean anyone can learn how to throw as fast as the fastest pitchers? Well, not quite. Even though there are thousands of professional pitchers, there have only been a few who've been able to throw faster than 100 miles per
The
hour.
Reds.
Like Aroldis Chapman.
Told you.
He holds the world record for the fastest pitch ever thrown, 105 miles per hour.
Woo!
So how did he do it? Well, scientists who study the human body think that one of the reasons pitchers like Aroldis Chapman are able to throw faster than anyone else is because some people's ligaments are just stretchier than others. And the more they can stretch, the more energy they can give to their arm when they throw.
That guy isn't throwing very
How
hard.
stretchy someone's ligaments are
Whoa!
might just be an ability only certain people are born with.
Gosh.
Some scientists also think that human beings will never be able to throw much faster than Aroldis does. That's because the ligaments in our arms just can't stretch much farther without snapping.
They
Just
do
like
break.
a rubber band would snap if you stretched it out too far. But even though people
Pitchers'
can't
arms
throw
do break
faster,
like that.
that doesn't mean machines can't. Meet the supersonic baseball cannon. It pitched a baseball over 1,000 miles per hour, the fastest pitch ever thrown.
Oh.
Its pitches are so fast that the ball
Whoa.
would explode if it ever hit a bat.
Whoa.
So in summary, pitchers are able to throw fast because they're really good at stretching the ligaments in their shoulders and launching the ball forward, like a water balloon launcher launches a balloon. Some pitchers are able to stretch their ligaments farther than other people, like Aroldis Chapman, who's thrown the fastest pitch ever. That's all for this week's question. Thanks, Eli, for asking it. Before you vote on next week's question, we put together some amazing visuals that we'd love to show you. Take a look inside, or if you don't have time, you can skip straight to voting.
So I'm going to have you guys do that on your own because there's some really cool things in there. So don't forget to respond to these questions and respond to one other person on discussion board posts. This is really kind of a cool thing here. I like when people and students, kind of have a discussion going back and forth with each other. So the next thing on here is we need to do the dissecting words in our language arts. So we're going to go ahead and open up that. Excuse me. Let's go to reading. Maybe if I open it up. And then we'll go to dissecting words, which is sometimes I got to wait till it loads before I start scrolling down. Otherwise it messes it up, which is on April 16. And there it is, dissecting words. I told you it was in there. Dissecting words, taking words apart. Why is it important to understand different parts of different word parts? When reading science texts, it can be challenging to understand some of the vocabulary commonly used to describe scientific concepts. Fortunately, if you're reading scientific content instead of listening to it, you can see the words themselves along with their different parts. These parts include the root, the prefix, and the suffix. You can also use what you know about the word's parts to figure out its definition. The root word can be made into new words when letters are added to its front and back. For example, the word smart is a root word when the letters are est are added to it. A new word is created, smartest. The group of letters that has its own meaning and makes up the end of the word is a suffix. Look at the word smartest again. The suffix is est, which means most. This tells us that the word is the smartest, means the most smart. The prefix in the group of letters added to the beginning of the word. This group also has its own meaning. For example, consider the word semicircle. This word's root is circle. The prefix is semi since it has been added to the front of the root word. Semi means half. This means a definition of semicircle is half a circle. Suppose you're reading a scientific article and you see the word dehydration. The first thing you should do is dissect it or take it apart. The word that you can look at carefully of each part of its meanings. Then you try to figure out what each part means. One way to figure out the word part means to think of the other words at the same part, which these words shares a prefix with dehydration. Dissolve, decompression, or distance. Yes, decompression, because it has the word day or D in front of it. When you see the words that share a suffix with the same creation, click the words if you see that word. So let's see here. Dehydration. Oh, look, hydration. Yes, this word contains ation, A-T-I-O-N. So, you can think of a prefix and suffix as clues to the mystery of the word's meaning. Let's begin by examining the prefixes in more detail. We'll study the prefixes in the following chart. After studying the chart, read the box on the left in the slideshow activity below. Answer the question by moving the circle on the left to the circle on the right. That is the correct answer. Then we'll click the next button. So hydra, related to having water. Gastra is a disease of the digestive system. Derm, dermatologists or doctors, skin doctors. Sun, sonar, using sounds to navigate around. Pangea is supposed to contain all the continents. And turb, like turbulent water that twirls around. All right, so we're going to move this to the correct one. The word itis usually means some type of medical problem. So we could say skin condition? Sure. Which phrase is dermatitis? So there you go. Derma, skin, dermatitis. The word emic refers to disease. Which phrase defines pandemic? A disease that affects people all over the world. Should have known that one, right? That's something I think everyone in the world knows that one now. The phrase turbid, a liquid that has been stirred up, a liquid that's been sitting for a long time. Turb means whirl. Gram is a message. It can take a form of a picture or word. Which phrase defines sonogram? A medical test using sound waves. Sometimes you get those if you want to find out what's inside your body. Someone who's phobic is usually scared of something. Which phrase is hydrophobic? So ready does not mean you're scared. Afraid of water. Very good. So, but in the end, once you learn the meanings of all commonly used prefixes and suffixes, you can really excel at reading about topics related to science. Now it's time to examine suffixes in more detail. We're going to study the suffixes from the chart below. So, ation means the act of, like vibration. Chrome is color, like monochrome, just the same color. Ism, state or condition, like dwarfism is a condition of being a dwarf. Ein or in, of or relating to, like saline is salty water. Os, O-U-S, it's like bilious, full of bile. And nonamy, knowledge or law, astronomy is the study of stars and planets. So cow is for bovine or bovine. Which phrase is for bovine? Related to cows, because a bovine is a cow. You've probably learned the word habitat. What does habitation mean? So living in a home or habitats. You know, a zoo and what it contains. What does zoonomy mean? It means the knowledge of animals. Remember, onomy is knowledge. Prefixes aqua means water. What does aqueous mean? Aqueous means full. Oh, it's a good one. Aqueous. Lacking water? I think it's this one. So, aqueous. You probably know what parasite is. What does parasitism mean? Say to being a parasite or full of parasites. Parasitism. I got a different understanding of what parasitism is. So let's go back to it. Let's find out what ism is. Ism means state or condition. So let's go there. State of being a parasite. See, use the chart to help you out. Alrighty, so I'm going to have you guys do these ones. Fluorochrome and dehydrated. I'll have you do all the taxonomy. I'll have you do this. What you do is you click on it and it tells you if you're right or wrong. You check, yeah. So kind of a self-check. I would strongly encourage you to do that before you take the dissecting words quiz. All right, so we've done everything on our morning. Let's go to our afternoon work. All right, let's start off with area versus volume. We've been doing a lot of volume this week, okay? So now we're going to compare area versus volume. Remember, volume is simply length times width times height, and area is just length times height. Volume measures a three-dimensional object, and area measures a two-dimension or 2 dimensions, 2 sides. Let's open this up. Come on. Click, click, click. And we'll go to April 16. area versus volume. Dun, 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 dun. So we'll watch this video to see the difference between a 2D versus a 3D. And Miss Stevens is going to be the one presenting this one. Oh, I need to do that.
Stevens, and I'm going to be helping you with problems that deal with comparing units of area to units of volume. Okay, let's look at units of area, like a square foot, okay? Now, when we talk about a square foot, we're talking about a figure, a flat figure, okay? So this is a two-dimensional flat figure. All right, and it would have a length here of 1 foot and a height of 1 foot. Okay, now let's talk about cubic foot. Well, a cubic foot has an added dimension. So it's 3-dimensional. Okay, so a cubic foot has a length of 1 foot, a height of 1 foot, and a width of 1 foot. Okay, so you can kind of think of it this way. Say a square foot, okay, that's length and height, and then a cubic foot has a square foot has 2 dimensions, a cubic foot has 3 dimensions, okay? Length, width, and height, and they're all 1 foot. Now, does this drawing show a square centimeter or a cubic centimeter? Here it is it A or B? Okay, if you said B, cubic centimeter, great job. We have length, width, and height here, right? So that's 3 dimensions, which gives me volume or cubic centimeter. All right, and that's all there is to it. So have fun comparing units of area to units of volume.
So, we kind of talked about this. So if we want to find the volume of this figure right here, we go 1, 2, 3, 4. All right, so that's 4. And here, let me actually turn on my camera so that makes it a little easier. I can write it down. And does it switch over? Because I have a new camera plugged in. I don't know if it'll even let me do that. Will let me. Let me pause it. Okay, sorry guys. It's not letting me use that camera. I knew I would get it to work. So, so you can see here, 1, 2, 3, 4. Okay, so that's 4. So we have 4. And then we count up 1, 2, 3. So we do it times 3. And then we need to get our final one, just counting back. 1, 2, 3, 4, 5. So 4 times 3. So 4 times 3 is 12. All right? 4 times 3 is 12. We bring this next one down times 5. So 12 times 5. What is 12 times 5? One moment, it says, oh, what is 12 times 5? 60. Brand user might have said 60. But 60, well, cubed, because we don't have a, whatchamacallit, a units yet. Let's see if we're right. Yay, 60 cubed. Problem 2. Now here we go. Problem 2. So we have, I don't have to count them this time, 1 times 4 times 2. So 1 times 4 is 4. 4 times 2 is 8 feet cubed. You see how I put that unit there? The foot cubed? And that would be our correct answer. Bingo! We've been working on that hard this week, so we did a pretty good job. So far, you've learned to find the area of 4 different shapes, as well as how to find the volume of a rectangular prism. So what are the differences between volume and area? So here's how they're going to explain to you how volume and area are a little bit different.
Area versus volume. What is the difference? Look at the shapes.
there are 2D plane shapes and 3D solid figures. Area is the size of the surface of a 2D shape and is measured in square units or units squared. Volume is the amount of space inside a 3D shape and is measured in cubic units or units cubed. Let's break it down a little more. Because this is a 2D flat area, we are going to find the area or space occupied by the shape. We measure by using unit squares. Each side is 1 unit. How many unit squares can occupy this space? 1, 2, 3, 4, 5, 6. In this rectangle, we can fit 1, 2, 3 rows of 1, 2 squares each. So the area is 3 times 2, or 6 square units. 3 is the length, and 2 is the width. We then multiply length times width equals area. So 3 times 2 equals 6. If each unit was 1 centimeter, we would write the area as 6 centimeters squared. Look at this shape. Is it 2-dimensional or 3-dimensional? If you said 3-dimensional, you're right. Because it's a 3D shape, we are going to find the volume or amount of space inside the shape. To do this, we need to know how many unit cubes there are. There are 1, 2, 3 cubes height-wise, 1, 2 cubes width-wise, and 1, 2, 3 cubes lengthwise. So the volume is 3 times 2 times 3, which equals 18 cubic units. The height is 3. The width is 2. And the length is 3. To find the volume, we multiply length times width times height. So 3 times 2 times 3 equals 18. Again, if each unit was centimeters, we would say 18 centimeters cubed. Look at this present. We can measure both the area and volume. But how? We can think of the area as the wrapping paper, or area outside the box. And the volume would be the amount of space inside the box. Think of it like this. The area is the outside space of a 2D shape, like the wrapping paper. And the volume is the amount of space inside, like the amount the present can hold. Look at another example. How can we measure the area and volume? We can measure the area of the label on the outside of the can, and we can measure the volume of the amount the can can hold inside. Remember, area on the outside, volume on the inside. Here is a shape. Would you be finding area or volume? Because it is a 3D shape, we are finding the volume. Area or volume? Because it is a 2D shape, we find the area. Area or volume? Because it is a 3D shape, we find the volume. Area or volume? Because it is a 3D shape, we find the volume. Area or volume? Because it is a 2D shape, we find the area. Area or volume? Because it is a 3D shape, we find the volume. How much ice cream will fit in the cone? Review time. What is the difference between
centimeters squared, and centimeters cubed. Pause the video to think of your answer. Press play to check. Centimeters squared equals the area. Centimeters cubed equals volume.
Alrighty. She did a very good job of explaining the differences between those two. So nice work there. Remember, guys, you can always go back and rewind and pause to hear a concept again. That's the beautiful thing about doing these videos. The amount of space inside of a two-dimensional object is to the volume is the amount of space inside of a three-dimensional object. Modeling using tile squares, they model using unit squares. And area uses calculating units squared and volume and units cubed. So, area or volume. You complete a problem calculating the area or volume and come up with an answer of 20 meters cubed. Did they ask you to solve the area or volume? Well, if it's cubed, then you are correct. You're asked to calculate how much space this occupies. Is this area or volume? Since it's two-dimensional, it is area. You're asked to calculate how much object this space occupies. Area or volume. Just a 3D shape, it is volume. And that takes you guys to your quiz. And here's a quiz. It's area versus volume quiz. A 3-question quiz. And the next thing we need to do is do our brain pop, which is called waves. So you guys can always get into brain pop anytime you want. You simply just go into Clever and you do your normal sign in as a student for Clever. I'll sign in with my teacher information. And then all you simply need to do is click the brain pop logo. And it'll take you right there because it's saved there. Now in the summer, I know they restricted a little bit, but I'm not sure. It might actually be available in the summer. Don't count on it, but I think that it might be available in the summer. So here is our video today. This one's about waves. This is another science one because, like I said, our science test is coming up soon. Has anyone ever done this before?
Dear Tim and Moby, are light waves, sound waves, and ocean waves all the same thing? From Danny.
Danny!
Well, all waves do the same basic thing, transfer energy from one place to another. But physicists divide waves into two basic kinds, mechanical and electromagnetic. Ocean waves, seismic waves, sound waves, and slinky waves are all mechanical waves because they need a medium to move through. Well, a medium is any kind of matter that's disturbed by energy. That energy disperses through the medium in the form of waves, which are basically chains of vibrating molecules. Water waves move energy through the medium of water molecules. Sound waves can transfer energy through a medium of air, liquid, or solid molecules. Seismic waves travel through the ground, usually after an earthquake. And slinky waves move through the medium of individual loops. Slinkies are really useful for visualizing how mechanical waves work. You can think of each ring as an individual molecule. When you shake one end of the toy, you can see how that kinetic energy moves from one slinky molecule to the next. Mechanical waves may appear to move matter forward with them, but that's not the case. Just like with the Slinky's rings, a molecule disturbed by a wave will return to its original resting position after it's passed the energy onto its neighbors. Electromagnetic waves, like light and radio waves, don't need a medium to move through. They can travel through completely empty space. That's why light waves from the sun and stars are able to reach Earth. And why radio waves let us communicate with spacecraft. Well, mechanical and electromagnetic waves are different, but they can be measured in many of the same ways. This particular wave is called a transverse wave. It carries energy along the spring by making it move at right angles to the direction of the energy flow. Ocean waves and most electromagnetic waves move in a transverse pattern. The crest is the highest point of a transverse wave, and the trough is the lowest point. That distance between the midpoint of the wave and the crest is the amplitude. That's also a measure of how much energy the wave is carrying. More energy means a greater amplitude. The distance a wave travels in one cycle is one wavelength. That's measured by finding the distance between two crests or two troughs. Waves can be measured by their frequency too. The frequency is the number of waves that pass a given point in 1 second. It's measured in hertz or waves per second. And frequency is related to wavelength. A wave with a short wavelength will have a high frequency, while a wave with a long wavelength will have a low frequency. Right, sound travels in compressional waves. Unlike transverse waves, compressional waves displace matter back and forth in the same direction as the energy of the wave. Vibrations created by anything from your vocal cords to a drum head to breaking glass will push air molecules together, forming a series of compressions that travel through the air. Those compressing air molecules hit your eardrum, making it vibrate and sending sound signals to your brain. Like I said, mechanical waves need something to travel through. That's why you won't hear sounds if you find yourself in outer space, unless of course if you bring your own air. Well, that's about enough on waves for now. Say goodnight, Moby. Ow!
That's always my worst fear, is somebody does that with the Slinky there. So I think my video is paused. So I'm gonna fix my camera real quick. Give me a second. Try that again. All right. Well, I'm sorry. I tried, but I think my video is frozen there. Sorry about that. I promise you, I'm still here because you hear my voice. You hear me? If you can hear me, I'm here. Well, anyway, you can see my screen, so we'll go and work that way. So the last thing we're going to do, is scoop pad. Sorry, I almost forgot about that. 30 points of scoop pad for ELA this week. Not 40. Remember, we took off Tuesday. Monday and Tuesday, actually, because Monday was state testing. Let's go into social studies, and we got a couple states that we're going to learn about today. I believe it was Nebraska and Iowa, I believe. But anyway, that's the ones that we're going to be doing today. Have anybody been to any of those states before? I know that Aurora went on a big trip earlier this year. She went through many states, and maybe she went through some of these states that we're going to talk about today. But the states we're going to talk about today are Nebraska, Iowa, Kansas, and Missouri. I've been to Kansas. I've been to Missouri. I've not been to Iowa, and I have not been to Nebraska. Maybe I drove through it once. I don't know. But that's kind of just for me. I wonder about you guys, though. So let's see here. My watch is saying I have 10% left power left on my watch. Nebraska. Traveling further south, we have the state of Nebraska. Nebraska is the home of the Omaha, Ponca, and Pawnee peoples, as well as the Sioux, the Cheyenne, the Arapaho, and the Potawatomi. There are several forts and historic monuments in Nebraska, as well as Buffalo Bill Ranch State Historical Park, which is home of the famed showman scout William Buffalo Bill Cody. You'll see a lot of the renditions or examples of him in different movies. Iowa. If you travel further east from Nebraska, you will come to the state of Iowa. Iowa contains several state parks, including Pikes Peak, which is the highest bluff on the Mississippi River. It is a very important state agriculturally, so for farming. Even though it's not that large, Iowa ranks first in the nation in amount of grain harvested. There are slightly less than 100,000 farms, and Iowa farm family feeds enough food to feed 279 people. So without them, we wouldn't have good farming and food available to us. Kansas. Kansas is another important agriculture state. It has something that looks just like a squirrel, but we know it's a groundhog. Leading in wheat growing state, so it's the bread basket, a lot of people like to say. It has a lot of corn, sorghum, oats, barley, soybeans, and potatoes. Kansas is home to several state parks, including the Prairie Dog State Park, hence the picture of a prairie dog. Missouri. The early native people of Missouri were the Osage, the Sac, the Fox, the Ottawa, the Iowa. Yes, Iowa in Missouri. Missouri, Miami, Kickapoo, Delaware, Shawnee, and Kansas. Those are all different names of Native American tribes. So you can kind of see where we get some of the names of our states from as Native American states. Although the state is named for a Native American tribe, today there are no organized tribes left in Missouri. Kind of sad when you think about it like that. It's named after a Native American tribe, but no tribes exist in Missouri. There are several state parks in Missouri, as well as the Swan Lake National Refuge, the Mark Twain National Forest. St. Louis Union Station is opened in 1894. It's the historic national landmark, the world's largest and busiest train station. It was restored and redeveloped in 1985 as a festival marketplace with many specialty shops and restaurants. It also has that famous arch. When you get to St. Louis, you'll see that arch there. It's also home to many businesses and pretty interesting location. I have some friends that live out there, so we visit every once in a while. But that was a quick lesson, I know, because these are kind of what we call the flyover states, and Ohio will be one of them. And it kind of, it's they kind of get a bad rap for people kind of flying over them, like in an airplane. You get it. So anyway, Iowa. I'm realizing I'm gesturing to you guys. You can't see me because my camera's not working now. But anyway, this is your Nebraska, Iowa, and Kansas and Missouri quiz. Now I just want to recap our day, what you guys need to do. I'll start off here again. So Lexia, 20 minutes. Scoop had ELA 30, not 40 points, 30 points. The AL scientific process and quiz. The next thing you need to do is the mini mystery science number 25. I'm really looking forward to hear what you guys got to say about that. That's the baseball one. You should watch this part on your own. Dissecting words quiz, area versus volume quiz, and last but not least is your Nebraska, Iowa, and Missouri quiz. Well, without further ado, I will see some of you guys today in our individual meets. If I don't see you today, I'll see you Monday at Willis for our final time in person. I'm really hyped to see everybody on Monday. Bring a pencil, bring your computer, bring your headphones, bring a snack. Bring some water for our very last in-person quiz. I will see you guys all bright and early Monday morning in person at Willis Intermediate School.